So in our previous video, we're able to look at how we can actually make use of the one hot encoder, which was this one hot encoder, and also for that of the label encoder, and also for that of the ordinal encoder. We're able to learn the basics and everything you need to actually do to make use of them, how to use them in the properly way. So in this video, we're going to look at how you can actually select the best features for your machine learning model. You know, the features you select actually matters on how well your model is going to perform on a new data. So if you select the right features, definitely your model is going to perform far more better when you select on noisy features. So that's basically what we are going to look at in this video. So we'll be focusing on three main steps to select the features of your choice. The first we are going to look at is that of the SelectKBest, and the second one is that of the Variance threshold, and for the third one is that of the mutual info classifier. These three are the best way you can actually select a feature of your choice, and these features actually give your model an edge. These three features selection, there are a whole lot of them, a lot of the use of the chi-square test you can actually use to select your features, but we're going to focus mainly on these three aspects. So for us to make use of this SelectKBest and make use of the Variance threshold, and also to make use of the mutual info classifier, so we need to actually import it, and they are all actually from that of the Scikit-Learn feature selection. So what you need to do is to where we are actually be. Let me just comment this guy out so it will slow down our terminal from running. So we're going to say from that of the Scikit-Learn, on the Scikit-Learn dot feature, which is feature selection. So let me just select it. We want to import our the SelectKBest, which is this first guy. We also want to import our variance threshold. We also want to import that of the mutual info classifier, or can say classif. And also something else that this SelectKBest actually uses a function that it actually used to score or to select a particular feature that it make use of, which is, you can actually call it f_class if. So this SelectKBest make use of this or the function to actually work properly. So the first step we're going to use, we're going to make use of this SelectKBest. So I have a data that I want us to actually make use of. This is just basically this type of this is actually this data, but from what we actually got from our one hot encoder, label encoder, and that of the ordinal encoder, I just set the values. Let me actually paste them. So you can see that from I just added this extra parameter, which is this experience, this color, salary, age, and gender is actually what we have actually been using, as we can see here. Remember that in our label encoder, we gave this red that we see here as that's 1. Sorry, that is 1, and the blue was 0. So yeah, that was 2, blue was 0, and 1 was for that of the green. So I just set the values down there. So for this of the gender, where female was actually giving 0 and male was actually giving 1. So that's just basically it. And also added for just only this of the experience as the extra parameter. So for this, we need to actually have what is our features and our target. For this able to work well. So our features, you can say the independent variable, we can set it as X. This is a capital letter S. Most of the time, this is actually how it's basically being used. So I'm going to query this of our data frame. I'm going to make use of this of the iLock. Remember, I've talked about this. This iLock just make use of the formula of that of the R and C, which is the row, and that of the column. So the first, I want the entire row, and then the column. Which column do I want? This is going to be my features, and this is going to be my target. So it's going to be from 0 to that of the last position. So it's going to be from 0. I can start to say 0 here, but let me just leave it as nothing. So automatically it's going to be selected, and the Y is going to be when we say our y is going to be our target. I can say the dependent. This guy is going to lead to this guy. So that's just basically what it is. So it's going to be the data frame or what ilog. This ilog is the index type of can say this type of grabbing a particular element. So setting the index here, we can actually grab that of the element. So we can say our ilog, we want the entire row, and then of course we want the entire. We only have 4 rows here. How are we going to use some and leave some? So the entire row is, we're going to make the entire row, and that of the column, which column do we want to be our target? So I want this experience to be our target, so I can actually set it to -1. So not leading quote, so it's going to be directly to that of the -1, which we know that -1 is the last particular element in the list. So I think this actually settles it. So for this of the what is it called, this SelectKBest, so we are going to actually get it, because that's the first guy we are going to make use of. So we are going to paste our SelectKBest here. It doesn't have all these parameters. So the first parameter that we are going to actually set is that of the score function, and that score function make use of that of the f class if that we actually use. And then we also want to set our k. What is our k? This k signifies the, you know, the way this SelectKBest actually works is this: is all the features that you give it is going to select the best features out there based on the amount of k you set up for it. The k is just like the number of features that you want it to actually select as the best. Let's say in your data you have like about 500 features. So no, 500 is too much. Let's just say you have like 50 features, and you want to make use of the best 30 features. So you can set our k to be 30 in case you want to make use of the best 30 feature. But when we look at in our case, we already have how many features here, or how many can say how many entry here. We have like 1, 2, 3, 4 for our x, which is our x here. So we want to actually use the best 2 out of our 4. We want to actually know the best 2 features out of the 4 features that we are trying to you make use of this SelectKBest to actually get. So after that, the next we want to actually do is actually to give it our x and y. So it's going from that, it's going to learn from that of our input features and our target. So it's going to learn from our x and our y. Remember that this y is a small letter and this x is a capital letter. If you are still new to machine learning, I think you be seeing this kind of variable being used. Remember that you can change it. It's not a must. I just want us to make it a little bit of beginner friendly, not anything kind of complex, but I bet you as we go on, things it's not going to look as simple as this. So since we have this model of it, then we are going to fit our model, we're going to use this of the SelectKBest model. We're going to fit it on our data, which is this data experience and the age and other guys. We're going to fit it. We're going to try to make use of this of the x to map to y and which features perform really well. So it's going to score all the features and then it's going to select 2 best from there. So that is what is actually going to happen. So after we are done, you're going to fit and then get that of the best 2 features that map to our target. So the next, because after this, when we are done doing this, when we get the output, it's not to actually give the features out for us. But let's actually print our output. Then we can actually do other stuff that we want to actually do. So we're going to set our output. So we're going to print our output. Remember that this output is referring to when the model was actually trying to learn from our data, and then it's going to implement from what it actually learned to actually make use of it to actually get other stuff. So as we can see here, we get these 50,000, 60,000. From the look of it, we know that it has selected this of the salary column, and then 2010, it selected this of the color column. You can see it has selected the best 2 column out there. So let's say we want to increase it to 3. Let's say we want to make use of the maybe 3 columns. So we'll actually see the three best colon out there. Definitely from the look of it, we know that it's definitely going to be this of the age. The gender doesn't really play much role in this kind of data. So since we have actually, okay, it's still running. So the next we want to actually do, when we look at this output that we got, we didn't actually get the colon. So I know by okay, you can see that we got 23, 35, 29, 40. I definitely that should be that for that of the age. So we selected that of the age, salary, and color because we said we changed the k to be 3, but let's just still leave it at 2. So since we have actually gotten this output, we need to actually most of the time we need to actually just make it to look a little bit better, like giving it a colon name and other stuff, because like this, nobody most of the time, if it's select, let's say you are dealing with almost 100 rules, so 100 features, there's no way you are definitely going to know which one is actually selected, especially when some of them tend to relate to relate to similar to each other. So let me just comment this out. We're going to map each of the colons to give it a particular feature or a colon name. So let's actually look at, we can say the selected, we can call the selected colon, like the colon that was actually being selected. So to actually do that, to actually get the colon that was selected, so we are going to do what, say the model dot get what support. Simple as that. If we say the model dot get support, we are going to set the indices to be what? We are going to set it to be true. So this is going to be true, right? With this, we are going to, it's going to give us the or the particular colon that was actually being select. I can say the feature name that was actually being used. So in our case, we're expecting to, when we try to get this select colon, we should be getting, since we set it to 2, we should be getting this salary and color as the output. So from there we can actually then map. Let me just comment this out. Since this our data frame here already has the output, so we'll try to make a list comprehension. What is list comprehension is going to do? It's going to go to our, okay, let me just do this. So it's going to be our data frame dot what colons is going to be index X. I'm going to explain what we're actually doing here. So remember when I explained the output is going to, this select colon is going to give us, the output is actually going to give us, going to be that of the index and position of each of the colons. So it's going to give, this is 0, this is 1, so it's going to give us 2 and what 3. So these 2 and 3 referring to that where that of the column name actually exists in our future. So we can create a list comprehension. We can say for X in what? For X in this of our selected column. So for this our selected column is going to be, we know that it's going to be a list of that comprised of 2 and 3. So but let's assume that we don't know that. So it's going to be data frame column index, the columns index 2 and that of the index 3. Let's actually see that. Let's not do stop much of the talking. The next one we're going to do for that of the variance threshold, and then lastly we are going to that of the mutual info class. Okay, what is the problem? Do you mean columns? Data frame has now attribute column. God, what did I put here? Columns. Okay, let's actually run this again. Sorry, I this small mistake on the name. So let's say for C running, let's actually look a little bit how this variance threshold work. The variance threshold work similar to this of the SelectKBest, but is where how it works is this. Variance threshold tend to drop a colon that tend to exist, that have all the data points need tend to exist, tend to reoccur over and over. Let's say in a situation whereby this of our let's say our gender, for example, here it was 0 and here, okay, let's actually look at this. So you can see that we selected our salary and that of the color. So let me just set this back. So in case if we selected we set 3 here, so we all know that we are going to get our age, salary, and sorry, if we selected 3 here, not 1, so we are going to get the salary, and the age and that of the color. But we'll be wondering how can we actually get how why did he use this salary and color. He did this everything mathematically, and he computed everything for us. So, but he didn't actually show how did he weigh it, and which weight does this salary tend to have over the color and tend to have over that of the age, and so on and so forth. So, but we didn't actually get the percentage of that, but we'll still come to that. So let's talk more on this of the variance. Like I said, I was explaining it. This example, we have this something like 0 here, and then we'll have something like 0 here. When we make use of the variance is automatically going to drop this gender colon. The reason why it's going to drop it, because it's going to see this gender colon as less important, because they tend to reoccur the same, or I can say almost exactly the same thing. Let's assume that we have something like 1 here. There's a possibility that this variance threshold is still going to drop this colon, because they have the same, almost all the elements on it are basically the same. So it's not going to, model is not going to learn anything from there. So let's actually do for this of the variance. Most of the parameters is similar to this of the SelectKBest. So let me just get rid of this. So I think everything looks good. So let's actually see whether if it's going to, but let's actually set everything to 0 for us to see an example of this. So let's actually run this of a variance threshold. Like I said, the way the variance threshold actually works is that when each of the data points in a particular column are repeating the same output, it's going to drop it down. You can see, like I said, salary and color was what it actually selected. It dropped this of the gender down. So let's assume that this gender, we had the 1 here and 1 here. Remember, right now this data is not balanced. So 1 is corresponding to, amount of 1 is corresponding to the amount of 0. So as we can see here, this gender has actually been selected, because the amount of 1 now is corresponding to the amount of 0. So, but when we set this to actually 0, there's a possibility that this variance threshold is still not going to pick this gender. The reason is because now the occurrence of 0 have appeared 3 times, but why we only have 1 change. This is really useful and important, because this is one of the noise that actually make the models to go crazy at times. Because when you look at this, just imagine having a data that almost have 0, 0, 0, 0, maybe looking at almost like 80% of data having one particular element or one particular value. See that's actually going to make your model not actually know what it's actually even doing. So let's actually run this. There's a possibility that the gender is not still going to appear. The variance automatically do everything. So most of the time you don't need to set extra parameter or any other parameter, and it's going to compute it and give you the output. So most of the times you can say, okay, the gender was actually being selected, but as we will have like 100 rows of I can say let's assume we have like 100 rows of data, for example, for this of the gender colon, and then we're having something like 0101, and then all of a sudden, like almost the 70% of the data has that of the 0, or maybe the male tend to appear more. Maybe you can see that is not going to train any machine model really well. What it's just basically going to do is going to throw each of them off. Like it's going to throw the model off. It's going to make the model to be biased, and like can lead the model to that of overfitting, underfitting, and a whole lot of messy things that the model actually doesn't really want. So with help of this variance threshold, we can actually stop that by throwing some features that is not actually doing really anything for us on our data. So the next we want to actually look at this of the mutual info classifier. This mutual info classifier is actually this type of what actually this guy actually does is actually to actually give us the percentage, or I can say give us the actual weight of what the model actually what it actually give each of the feature. When I mean that, let's assume that when you scale them on 100% importance, it's going to assign each of these features and the importance or based on percentage. Let's assume that this salary now is going to be giving, since this salary and color tend to be one of the, I can say 2 of the best selected, so this can be maybe 30% 25%. These guys are going to be given their own percentage. So let's actually see that, and then maybe we can actually tend to understand it really more. So it's going to, let me just copy this guy. This is mutual info. Remember, there are still a whole lot of other these guys you can actually use there. So it's going to take the X and that of the Y. So we're just going to come what I do. So it's going to, we're going to comment some of all this guy out. So let's actually comment all this guy out. So down here we're going to, what are we going to do? So we can say for, because the way it's actually being stored is actually, you have to actually get the score. So if you print the model, it's going to give us the score. But most of the time, it makes a good sense if you actually know the model and the feature name and the score that it actually gives you. So you can say our feature. This our feature is going to directly, we're going to refer to our data frame, which is of the DF that we have here. So we're going to say score that actually give it, they can actually call it importance in what want to actually zip. What do we want to zip? We want to actually zip our data frame, and we want to actually zip the model. Simple as that. So let's actually bring this down. So here we can actually print, because say for future, what have I done? So this is going to be print. So we can say want to get the future, and then want to get the score. Simple as that. So with this, we have actually solved our problem. So the feature is directly referring to, so this is the data frame dot what? Colons. Simple as that. So the feature is going to be the data frame dot colons, and the model is going to be a list that has all those scores on it. So each feature now has its own score. Let's actually run it and see what the output that we from the result that we got here. We got a found array, 0 sample, 0 shape, y minimum, 1 required. The most of the problem that occurs, the problem that I can see that basically occurs with this is that because when you look at it, our data is actually really small. So some computation that is not capable of doing because our data is actually really small. So, and actually there's a good way to handle that. So we can say our discrete, it's called our discrete underscore what feature. Okay, the VS Code is already here. So I can say discrete dot under feature. I can set it to true. So let's actually run this again. So as we can see here, we see that by setting that of the discrete equals to discrete feature equals to true, we're not getting that of the error. So we can see from what we actually see, you can see that on this or the feature that we actually set, you see that gender was given 0.56. Hope that is not, it was being weighed 0.56, and this of the age was actually weighed 1.38. Can see that, and the salary was actually weighed 1.386. The same thing with the age, and the color was actually weighed 1.03. Now you can see almost 1.04. So you can see from the look of it, by making use of these three guys, that of the variance threshold, SelectKBest, and this of the mutual info class, if I can say classifier. So these three guys give you a full insight on how your features, the importance of your features. You can see that you can see the reason why that of the SelectKBest pick these two guys, this salary and color, because it weigh them more. Even if the mutual info class, if actually tend to weigh these age and salary a little bit more. I can say they are almost the same thing. So you can see that on everything, the salary tend to be way the highest. Not the highest, it's basically the same thing with this guy, but when the two guys salary tend to appear, and this color tend to also was actually good, because on a non-shade, if we think of it in that way, it makes sense, because even though this guy come to appear the third guy on this of the mutual info class, and this salary was the first, I can say, and the age was the first. So this telling you that this salary is really important feature that can actually make use of in your machine learning mode to train your machine learning model. And this color is also like a good average guy. So, and this age was, like I say, when we set out of the K to 3, age was actually being picked. I can see now this is becoming to make sense. So when you are doing your training your machine, rather than make use of adding age that doesn't actually add any value to it, you can actually just go with these 3 guys. They will actually train your machine learning model really well. But training each of the features away can actually affect that of your machine learning model. Your features can actually affect the performance of your machine learning model. That is where what we call actually that of the train, test, and that of the split comes in. And this guy actually is really important because this actually guy is just it splits your data, bring out some for training, some for testing, and reserve some for other purposes. So this is what we're going to look at in the next video. That's basically what we're going to do. What is actually that of the train, test, split in the next video. So but here's a recap of what we actually looked at in this video. We actually looked at the SelectKBest, Variance, and that of the Mushua class. This guy is actually a score function that this SelectKBest actually makes it. There are a whole lot of other score functions that this SelectKBest actually make use of. So this variance threshold, what it actually does is just to drop a particular column that doesn't actually add any value to the data itself, or maybe it has occurred multiple times, keep on appearing multiple times. The values that are on it appears so much that it's almost more than 70% of the data, or can say the set of data that it actually appears on. And this SelectKBest, what it actually does is going to with help of the fit and underscore transform, is going to fit the model, understand the model, learn everything about that of the on your data. It's going to fit and learn everything about your data, and then it's going to give you the best features that you can actually use. The same thing with this of the Mushua that shows you the percentage, or not the percentage, the actually weighing of the results. So I think this actually concludes. If you find it useful, make sure to subscribe. I'll be able to see you in the next video. Thank you for watching.